I am Artur Chmielewski. I am from the Jet Propulsion Lab in Pasadena, California, and I'm the US Rosetta Project Manager. And the Rosetta mission is a mission to a comet. The target comet is Comet Churyumov-Gerasimenko 67P. Comets are named after their discoverers. In this case, there were a couple Ukrainian astronomers, Churyumov and Gerasimenko. I have a 3D printer-generated model of this comet. Of course, it's a tiny scale model. The actual comet is about 2 kilometers by 4 kilometers, maybe a fraction of the size of San Diego. So this is the comet Churyumov-Gerasimenko 67P. It's a periodic comet. That's what P stands for. And ESA leads the mission that investigates this comet. There was an ESA spacecraft and a German DLR-led lander that landed on this comet in November last year. It's a very exciting mission. We've been flying to a comet for 10 years, and now we've been orbiting it for about a year. Also, we have a lander on the surface that landed about 6 months ago. This was a very exciting landing, more exciting than we bargained for. But the lander was supposed to land in an area that was selected out of 10 landing sites, and it was in this area here, right on the what we call the minor lobe or the head. And because it's a very low gravity object, we had to have harpoons that fired at the moment of touchdown to hold the lander down. And at the same time, there would be a jet firing on the top of the lander to press it down. So you press down the lander at the moment of touchdown, and then you fire the harpoons to hold the spacecraft down. Well, neither one of these systems worked. The harpoons did not fire, and the jet did not fire. And it's kind of lucky that both of them didn't fire. It would be worse if only one worked. But because of that, the spacecraft landed and then flew over half of maybe the head of this amazing duck and hit one of these hills here and landed in a ditch, kind of like a golf ball would end up in a hole. But it landed in this crevice in such a way that was hidden from the sunlight and was hidden also from the orbiter that keeps on orbiting the comet. So we lost communications with the lander. The lander did work for 2 days as designed on a primary battery. And it returned data from 7 out of 10 instruments on board of the lander. So that was very exciting, because now we have measurements from the orbiter that looks at the comet, and the orbiter has 10 instruments on board, with one of them being a consortium of plasma instruments. So it's a total of 16 instruments, and the lander has 10 instruments. So it's a battery of scientific instruments that is studying this comet continuously. We've been looking at the comet now for about a year and learned a lot of things. One of the exciting results was that the water that is in this comet is different water that is on Earth. And that was one of the questions. Earth, at one point, became a very dry planet. There was no water on Earth sometime 3.5 billion years ago. And then something happened, and the water came back again. What is it? What happened? What brought water back to Earth? And a lot of scientists expect that it was comets. That comets, during bombardment stage, when there would be 10,000 comets puncturing Earth every year, there would be a lot of that water would deposit on Earth, and that's what formed our oceans, our rivers, our lakes. So we wanted to see if the isotope of water is the same as isotope of water on Earth, and it was not. So that means that water that is on Earth did not come from this type of comet. It doesn't preclude other comets. Comets have different ratios of D to H ratios. Other fascinating results were obtained due to the actual failure of the harpoons. What became tragedy for a couple scientists whose instruments did not work because the lander did not attach itself became actually an amazing event for example, for magnetometer people, because instead of getting a measurement in just one place, they got several measurements as the spacecraft was flying. And on that basis, they were able to determine that there's no magnetic field on a comet, which also pins the comet formation to certain era in the development of in the formation of the solar system. We will be flying and orbiting the comet until September 2016. And there will be, at that time, a very exciting culmination of this mission, because the scientists and operators decided to put the orbiter down on the surface of the comet. And so we're really looking forward to this event. We're going to have very good close-up images of the comet. So one more year, and then we'll have years to come to analyze this data, and then extrapolate our results from exciting instruments in microwave, ultraviolet, infrared, from mass spectrometers, put them all together, dust instruments, put it all together, and see how that then translates into the modeling of formation of the first days of the solar system.